let's continue talking about different types of angles. If I draw a circle centered at the endpoint of two rays defining an angle, piece, I guess I could say a piece of the circle between the rays. And I'm not going to be too careful about defining between because it can mean numerous things. Between the rays is called an arc. That's the arc of a circle. That arc is said to subtend the angle. This is a fun new verb. If the circle is a unit circle, so meaning a circle of radius 1, then the length of the arc subtending an angle is its measure in radians. So, from basic geometry, we know that the circumference of a circle is 2 pi r, which is 2 pi for a unit circle. So, the measure of 360 degrees in radians is 2 pi. And from there we can do all sorts of conversions. So, for example, if I know that 360 degrees is 2 pi, then I can use 360 degrees over 2 pi to translate between radians and angles, and degrees. So let's multiply this by pi radians. Let's try to figure out how many degrees is pi radians. Well, I cancel these, and I've got 360 divided by 2, which is 180 degrees. So we can use 360 divided by 2 pi to convert between degrees and radians, or pi over 360, however what you want to do it. And you can also think of it as pi over 180, or sorry, 2 pi over 360, or pi over 180. Some people like it one way or the other. So next, the length of an arc subtending, of a circle of radius r, subtending an angle theta, is S, which equals r theta. And this is a very important equation. We're going to be using this a lot in the future. Next, the area defined by 2 rays and a circular arc is A equals 1/2 theta r squared. So this is the area of a circular sector. And to give you some sort of ideas, this would be a circular arc, and this would be a circular sector. This is sort of like pie slice or piece of pizza. Okay? So let's do a couple of examples using these. Find the angular speed of a wheel with radius 2 feet. So remember, we use this little prime to denote minutes for degrees, but I'm telling you this is a radius. This is a length of a measure of length, not a measure of angles. So 2 prime means 2 feet. Radius 2 feet, traveling at 3 feet per second. Okay, so I've used this notation for feet, and I've also used ft for feet. All right, so I'm not trying to be confusing. I'm just trying to show you the different some of the different ways you can indicate feet. So how do we approach this problem? What is the angular speed? Well, so if speed is distance over time, angular speed is angles over time. Okay, so solution. So we're going to be looking for either degrees per second or radians per second. So the wheel, let's draw a little picture. Here's a wheel of radius 2. Oops. And as it's rolling, right, it rolls in this direction. So let's say it rolls, this part makes contact here, this part makes contact here, this part makes contact here, etc. As it rolls through one revolution, how long does that take? Right, so we can figure out how quickly the thing is going. So as it goes 3 feet in 1 second, how many angles did it go through? That's kind of what we're trying to get at. So if we know that it goes, so the wheel comes into contact with 3 feet of the ground every second. So then we use our equation, S equals R theta, and we plug in what we know. So S is going to be 3 feet equals the radius, which is 2 feet, times theta, the number of angles that it turns through, or the measure of the angle that it turns through in 1 second. So we just divide both sides by 2 feet, and we get theta equals 3/2 radians per second. Now, if you wanted to, we could convert that to degrees, but you don't have to. All right, for another example, another sort of straightforward example, and this will finish out this section. What is the area of a slice of 24-inch, so I'm using the 2 primes for inches, pizza, cut into 6 equal pieces? All right, now we have to be careful here, because when I go to the pizza shop, what do you call it, restaurant? Pizzeria? Okay. It's been so long since I've been to a pizza place that I can't remember what they're called. Yeah, pizza place. When I go to the pizza place, if they sell me a 24-inch pizza, what does that 24 inches correspond to? Well, the 24 inches is going to be the diameter of the pizza, right? So that means that our radius will be 12 inches, okay? We're going to use the formula A equals 1/2 theta r squared. Now, what is my theta going to be? So I'm trying to find the area. I know the radius, so I need to find theta in order to plug into that equation. Well, if a whole circle, if 360 degrees is the whole circle, right, and that is 2 pi. Then I need to divide that by 6. So that would be 60 degrees, or pi over 3 is 1/6 of the pizza. Right? And these are equal pieces, so we know that it's going to be exactly 1/6. So that's going to be my theta. So I plug it in, I get a equals 1/2. Theta is pi over 3. And r squared, so 12 squared. So I get, what is this, pi over 6 times 24, times 12 times 12. But these will cancel, we'll leave 2, so I get 24 pi square inches. Okay, so you could write SQN or sometimes IN squared. Either way, I'm not going to be too fussy about units. I just want to show you a bunch of different ways to write these units. Hopefully this made sense.